hosts on the line. When you are
Hello and welcome to this Cimlogic webinar, OEE, the critical KPI to drive manufacturing productivity. My name is Hannah Scott and I'm your facilitator for today's webinar. Today's webinar will be recorded and we ensure the recording is sent out to you within the following days. We want to make this webinar as interactive as possible, so if you have any questions as we go through the webinar, please use the questions panel on the right-hand side of the screen and we will address these at the end. If we run out of time, we will answer your question by email. Further information about Cimlogic, our solutions and services can be found at www.cimlogic.co.uk. If you have any further queries, please do not hesitate to contact us at enquiries@cimlogic.co.uk or on 01274 599 955. Now, without further ado, I would like to hand you over to Fraser Thompson, Business Development Manager.
Thank you very much, Hannah. Right, so just before we get on to the main topic of the webinar, just a little bit of an overview about us here at Cimlogic. We're based over in a lovely part of the world in West Yorkshire, a little village called Saltaire. That's our building on the left-hand side of the screen. And we pride ourselves on providing manufacturing improvement solutions to some of the world's largest manufacturing companies, primarily in the UK and Ireland, but also further overseas. Part of what we do includes providing software solutions, consultation and support services, but all with the focus of manufacturing improvement. So that's a little bit about us to get us going. Myself, that's me in the picture. I'm the Business Development Manager with Cimlogic, and I've been working with the company now for 8 years. My background was as a controls engineer before moving into sales with an MES focus, really, and that's partially where OEE as a solution sits within this MES layer. For those of you that aren't familiar with MES, I've got various other webinars that you can watch on our YouTube channel that will give you an overview of some of the other areas we can cover. So let's have a look at it. So OEE, what does it stand for? Well, the first thing from the top of the slide there is it doesn't stand for overall equipment efficiency. What it actually does stand for is overall equipment effectiveness. And that's quite important because what's efficient isn't always effective. If we are looking at a production line with a number of different machines on that particular line, making the machine at the start of the line as efficient as possible, making sure that it's running at 100% capacity all of the time, isn't necessarily related to the line as a whole performing in its most effective manner. If we take it back to sort of definitions, then efficiency will give you an idea of how well something was being done, whereas effectiveness will be doing that thing in the right way in order to achieve some goals. So OEE, a very good metric for manufacturing companies to drive the things on the screen. So increasing our capacity, decreasing the time to produce, increase return on assets, reducing operating costs, reducing labour, overheads, being able to better manage capital using the measure as a justification to purchase other equipment or machinery, and essentially increasing shareholder returns. So it is an effective methodology to help us improve the effectiveness, the productivity of manufacturing processes across industrial verticals. So it could be pharmaceutical, food and beverage, automotive, across different types of manufacturing. So, discrete, continuous batch type manufacturing processes. It's a measure that can be used in various different ways. Now, obviously, the title of the webinar and the focus of the webinar is on OEE, but it's important to realise that it isn't the only KPI that you might be using within your manufacturing process. There are many, some of which I've noted. It's not an exhaustive list, but some of them are noted there on the screen in front of you, including things like cycle time, on time in full, unplanned maintenance, inventory turnover, capacity utilisation, and so on. You can actually get a full list of some of the top manufacturing KPIs from MESA. And again, if you'd like to know more about that, you can drop us an email afterwards and we can send you some more information. So OEE It's not the only KPI, but it is quite important. If you consider OEE with respect to all of the other KPIs that are on the page in front of you, they all either have an impact on OEE or they can all be impacted by improvements in your OEE. So for example, improving my OEE from 40 to 50% should also give us greater capacity utilization, or improving our changeover time from 1 hour to 50 minutes should have a positive impact on our OEE. So they are all linked. We can link them all together. So OEE, yeah, it's not the only thing, but it is quite critical, and that's the focus of today. How's it calculated? And then for those of you that are perhaps new to the subject on the webinar today, it's made up of 3 main components. Availability, again, which, as it says, there is a ratio of operating time to planned production time, also known as perhaps downtime. Performance, or sometimes we'd abbreviate that to P, and again, this is subjective, but I'm going to call it the rate at which equipment converts available time into product. So if my machine is designed to run at 100 bottles per minute and it's only running at 95, there is a performance loss of 5 per minute. And the final part of the puzzle is quality. So of all of the items that we produced, how many of those were good saleable products and how many of them did we reject or turn into scrap? An important note there is that reject and scrap aren't necessarily the same as rework. If something is reworked and put back into the system, it may need to be measured differently, but you could say, for example, that if you produced 1 unit and it had to be reworked, you could have produced 2 units in that same amount of time, and therefore there is a 1 unit impact on your OEE score. So that's the calculation. OEE is, in a percentage term, the percentage availability multiplied by the percentage performance multiplied by the percentage quality. And it says at the bottom, availability is downtime losses, strictly speaking, performance is speed losses, and quality is defects. Alternatively, if you don't have the full level of detail for availability, performance, and quality, then you could do a simpler high-level calculation that should give you the same calculation. So the OEE should be the total saleable units produced over the maximum theoretical units. The percentage that it gives you, 65, 45, 22, should be the same regardless of which method of calculation you've used. If there are some differences, then perhaps there are some issues with the data that's being pulled into the system to do the previous calculation. So how do we make it up? It's all very well saying it's availability times performance times quality losses, but when we consider, let's take a day in the life of a production facility, we've got a total available time, if you like, of 24 hours. Now the first thing that happens is we might have some planned shutdown, so we might only be choosing to run our facility for 1 shift or for 2 shifts, so we might only choose to run for 16 hours out of the 24. So that remaining 8 hours time is a planned shutdown. And quite typically, you would take that planned shutdown outside of the OEE calculation, as you can see on the screen in front of you. That could be, as we say before, that we don't have a shift to run. It might be that it's a bank holiday and we don't produce anything on a bank holiday. We don't have a labour force in. But it's also something that you might want to capture. So what a lot of people tend to do is also do a calculation that includes the planned shutdown that we would call TEEP, or total effective equipment performance, and that would indicate more of a complete capacity utilization. So you have this machinery, you have this plant available to run. It could run on a night shift should you choose to put a night shift on, but the fact that you haven't chosen to put a night shift on is still potentially lost. You've got the assets there available that are able to produce, it's just you're choosing not to use them. But for initially, we're just going to focus on, let's take the planned shutdown time out of the calculation. So once you then consider any downtime losses for the line or for the machines, you reduce the amount of time available to you to produce items by the availability loss in minutes or hours. That would give you an operating time. And then we would look at the speed losses or any performance losses that might have occurred during that operation time to give us a net operating time. and then we'd take off any of the quality losses, converted into a time metric to give us this total productive time. So this is essentially the time that we could have produced, the same amount of units that we did produce, if everything ran 100% perfectly. Bit more detail on there. So downtime losses, availability, the ratio of operating time to planned production time, just going through the various different calculations of the three. And again, the slides can be distributed after the event, and you'll have all the details of the various different calculations on there. So, a couple of caveats really, is within each of the OEE categories there are several events that must be identified correctly, measured and analysed. So for example, it may be that for very short stops, so let's say my line stopped for 10 seconds and then it started again, which bucket of losses should that 10 seconds appear in? And there are a couple of different schools of thoughts. The first thing to say is that it's important that you capture that. And if you captured it, you can record it, you can report on it, you can analyse whether it's an increasing trend or a decreasing trend, whether you need to do anything about it. The question here is, which bucket should it go into? Should it go into availability losses or should it go into performance losses? So there's a couple of ways you could do it. You could put it in availability loss and then it's grouped in with all the other downtime events, or you could put it in performance losses. One of the areas where you might consider doing that would be, for example, a stop that wasn't related to a fault on a machine. So let's take a labeler, for example. Let's say the labeler stopped because you needed to change the reel, splice the reel on to the end of the old reel and so on. It's a function that you need to do because of the setup of the line. The machine isn't in fault, it's not showing any alarm status, you've just got to perform an operation on it. And some people like to group those events together and put them in the performance loss bucket rather than the availability loss bucket. Quite typically, people might look to say the availability loss bucket should be indicating items where engineering or maintenance need to get involved and look at corrective actions, whereas the performance loss bucket would be more for the operations team to look at corrective actions on. There are many different ways to do it, but most importantly is that we capture that time. But there are many things that can affect your OEE. So we've already talked about speed, we've already talked about short stops, faults, alarms. It is just important that we capture them, but also how we measure them. So if we're looking at a line as a whole, do I measure my OEE for the line as a whole, or do I measure individual OEE metrics for each of the key machines? And again, many different schools of thought here. Some people would call OEE of a line OLE rather than OEE, and some people might consider OEE of a machine to be a slightly false indication because the speed that machine 1 on the line can run at is impacted by the speed that machine 2 is running at. So it can give you false readings. It's important to take a wider view. And what the goal is, what are we trying to do? We're trying to get more product out of the door and work back your individual calculation from there. Also, quite commonly what you might see is a list similar to what you can see on the screen in front of you that people would call the 6 big losses. So as you can see, there's 2 in each bucket. So there's 2 in availability loss that would be equipment breakdowns and process setup and adjustments. There's 2 in performance loss, short stops and idling, reduced speed, and 2 in quality loss, covering startup rejects and production rejects. This is kind of a well understood grouping of losses that can occur in a manufacturing process that's quite commonly used. So for example, an equipment breakdown hopefully is quite straightforward. There's been some kind of mechanical, electrical fault on the system. Process setup and adjustments is, again, if we're doing a changeover, what downtime occurs as a result of having perhaps incorrectly set up a piece of equipment or having to adjust the side guards, for example. We've got short stops and idling that would occur during general running, but also actual reduced speed. So we could run this particular product at 100 bottles per minute, but we're only choosing to run it at 80 bottles per minute. Straight away, we're giving ourselves there, or losing the opportunity to make 20 bottles a minute, and that would go into a reduced speed pot. And then from a rejects perspective, again, people occasionally like to group them into two different pots. So production rejects, things that happen when we are running normally, and startup rejects. Or also you could put shutdown rejects on there also. So rejects or scrap that occurs as a natural part of setting up the line or setting up the equipment. So that's a very common grouping that you might see. Now, take this slide with a pinch of salt. World-class OEE is quite commonly referred to as being 85%, and that's made up of 90% availability, 95% performance, and 99.9% quality to give you 85% OEE. Now that's great. It's something to aspire to, something to look to achieve in the future. But in reality, most plants that I visit quite frequently tend to have OEEs in the range of about 30 to 60%. And as it says there, they can fluctuate by up to sort of 10% a day, daily variations based on the shift that's running, climatic conditions, the snow, the weather, what products we're running on that particular day. So there can be fluctuations that you would expect. However, to get to 85% if you're currently set at 30% is going to be quite challenging. So what I would suggest is aspiring to world-class OEE is all great, is all well and good, but you need to set yourselves appropriate targets that will obviously challenge yourselves and your workforce, your operations team and your engineers, but targets that they can actually achieve. It may be that due to the profile of work, the profile of production orders that you receive, that you need to perform multiple changeovers in a day or in a week, at which point your ability to achieve 85% will be slowly degraded over time. It's much more common if you're doing a very short runs, multiple changeover type process to set yourself a target that's more around the 50% mark. So I suppose what I'm getting to here is world class is not always achievable in your particular industry. What's important is to benchmark and set yourself appropriate targets. In some research that was performed by the LNS group here, they've gone through a list of around 200 companies worldwide to try and benchmark OEE in their individual industries. So as you can see here, we're looking at batch manufacturing ranging from the lowest recorded of 58% to the highest recorded of 94%, life sciences 45 to 98%, process manufacturing 72 to 94%. What does that actually tell us? Well, the first thing I think it tells us is that people are artificially inflating the OEEs they're recording, because very frequently I'll see companies within the same sectors, in the same industries, that in reality, if you were measuring OEE to the book, would be more like 30 to 60. So it's important to take benchmarks or world-class OEE with a pinch of salt and set yourself an appropriate target in a organization whereby you produce the same product on the same line all week and you never change over, or you do one changeover a week. Then yes, getting into the 85s, 90% should be a target that you look to set yourself. But if you've got a different profile of work, you need to adjust your targets appropriately. So let's go through a real life worked example. We've got some dummy data, if you like, that we're going to take through a calculation. This particular example is taken from a drinks plant, and we're looking at a 5-day period of operation. So there's going to be 15 shifts, and we're in 3 shifts per day, 8 hours each. I've got a planned shutdown during the week of 2,400 minutes. And over those 5 days, we experience 1,250 minutes lost as downtime, availability loss time for faults, for whatever reason it might be. My line is going to run one size of product that always runs for those 5 days at 600 bottles per minute, or should run at 600 bottles per minute. And over the 5 days, we're going to record the total number of units produced, so just over 1.6 million. And of those 1.6 million, we rejected about 1,200. So using that data, we're going to put that into the OEE calculation and see what we turn out. So if we start at the top, we have a total available time, 5 days, 7,200 minutes, and we planned to shut down during that time for 2,400 minutes, giving us 4,800 minutes of planned production time. During that planned production time, we experienced 1,250 minutes of downtime, which gave us an operating time, if we go back to the calculation earlier, of 3,550 minutes. And in those 3,550 minutes, we produced just over 1.6 million bottles and rejected around 1,200, giving me a total good saleable bottle count of 1.655295. Throw all those numbers into the calculations. Our availability as a percentage would be the operating time over the planned production time, so 3,500 over 4,800, giving us 73%. Performance, so in the available time that we had, how many did we produce versus how many we could have produced at the ideal rate, and that gives us again 77%. And then when we look at quality, how many did we reject over the total volume that we produced, and that gives me a quality of 99%. Multiply the three together to give us an OEE for the 5-day period of 57%. And there we go, we'll have our calculation. So what does that tell us? It tells us that our OEE is 57% and we're some way off world-class standards if that should be our target. But the first place we should look is to say which of the 3 buckets of losses is causing us the most difficulty. So firstly, we would look and say 99% quality seems to be pretty good. Maybe that we can make some slight improvements in there, but 99.999% quality, for example, is a pretty good score. So maybe we need to focus more our efforts on the availability losses and the performance losses. And that's the start of the continuous improvement cycle. So we're starting to focus our efforts here, for example, on our top loss of availability. When we get into it, availability losses, what is our top availability loss reason? Is it one particular machine? Is it one particular fault, and so on? So that's the quick calculation. How much can we improve? This is quite important when it comes to justifications for capital expenditure. For example, maybe we want to justify spending an amount of money on a new casing equipment or a new labeler. What we can use the data for is to determine roughly the impact of a certain downtime or the impact of downtime on a certain machine, to say, how can we quantify that? Can we turn that downtime into a number of units or put a financial value on it? So the example here is if we take a 10% reduction of our availability loss time, so we're going to improve by 125 minutes, and assuming that during those 125 minutes we ran at the same average speed that we ran at beforehand, we would be able to produce an extra 58,327 bottles during the same 5-day period. Let's say, for example, there's a wholesale price on that bottle of 56p. During that 5-day period, we could have, if we'd have improved our availability losses by 10%, made an extra £32,669 worth of saleable products. Multiply that out over the course of the year, and you start to get some quite substantial numbers. So again, £1.698 million worth of potential extra saleable goods without having to put extra shifts on, without having to put overtime on, just by making a 10% improvement in our availability loss metric. And some of these numbers, some of these calculations can be quite striking to people if they've not done them before. So it's one of the things I would definitely recommend that you do. If you'd like to talk to me directly about how you go about doing that calculation or trying to help you justify various expenditures, then please do contact me to let me know and I can help talk you through it. So, global competition, obviously for those of you involved in exporting or competing around the globe, you need to be competitive. We need to be looking at how we can compete, if we say in the UK, with manufacturing activities that may be cheaper outside of the UK. We need to make sure that our manufacturing processes are effective. And I'll stop myself saying efficient, are as effective as possible. And really what I'm trying to tell you here is that OEE is a very key metric to help you do that. If we can produce high quality goods within this country at a good level of effectiveness, then we should be competitive with other parts of the world that are able to produce higher volumes cheaper. We need to make sure that manufacturing in the UK becomes the bedrock of the economy, really. So, how should you go about collecting data that will enable you to do an OEE calculation? Well, first off, a manual process is a very good start. A lot of people will be using paper around the production process, clipboards on the shop floor with people writing hourly production volumes and hourly downtimes that they've seen or experienced on the line down on paper. And that's definitely a very good start. The next step beyond that is to look to implement some kind of software that is capable of directly monitoring your control assets, your PLCs, your production equipment, to get a level of the real information. And that's quite an important consideration, really. Manual data collection is a very good start, but it certainly does have its drawbacks. It's obviously a time-consuming process. It's going to take somebody time and effort to every hour record how many units they've made, how much downtime they've incurred, but also it can be inaccurate. It's open to human error, it's open to manipulation, and it's open to just not seeing the full picture. One good example of that is speed loss. The speed loss is something that's very hard to tangibly measure manually because from an operator's perspective, the line is running, it's producing a number of units. Unless you stand there with a stopwatch and a ticker, it'd be very hard to determine the rate in a real-time way that enables you to see if actually you're incurring a loss or not. So manual does have its drawbacks. And when we talk about moving to an automated system, the very first advantage that we're going to get is that we're going to get real accurate information from the control systems. We're going to get accurate counts of how many units we've produced and when they were produced, and we're going to get real to the second indications of downtime events as they occur. And again, a good analogy to make here is that I'll often stand with a customer and the line behind them will stop for 10 seconds and perhaps they won't have even noticed that it stopped for 10 seconds. Essentially, that's a loss. We still need to capture it. It's very hard to capture that with a human eye and pen and paper. It's quite simple for an automated system to pick that up and put it into a loss bucket so that you can do some analysis and look to try and improve that. And once you've got all that information automatically, it's still important to add some context to it from real people. So it's important not to go from one extreme completely manual to another extreme completely automated. There needs to be a balance to give you, firstly, real accurate data from the machines that is not opinionated, it's fact, but it's also good to then marry that up with some level of description from an operator. Again, a good example would be a machine might tell us that a guard door was opened for 5 minutes and 23 seconds, but the machine would not be able to tell us why that guard door was opened. Only the operator that opened that guard door would have that knowledge, and it's important to capture that. Once you have captured all that information, what you're then able to do is to do all of your analysis, all of your number crunching automatically and present that in a variety of visual reports. Ideally web-based is accessible to everybody. And quite often if you're, again, recording downtimes and things manually, then you will perhaps be employing somebody directly to do that data gathering, entering it into Excel and then do the number crunching. If you're capturing information automatically, again, that step of the process can be removed. It's already been done, it's been done by a system, and the data's being logged and stored away in a database. And very quickly you can start to identify trends with speed, with downtime events, just by having that information readily to hand rather than spending your time gathering that information. So that's a little bit of an overview of why we here at Cimlogic believe that OEE is sort of the critical KPI in your manufacturing process, but it is only part of the puzzle. So we at Cimlogic offer a variety of solutions. Automated software for capturing OEE sits within the manufacturing operations management or manufacturing execution systems, MES, MOM area. Essentially, that's the software systems that's going to gather and present the information to you. But that is only part of the puzzle, really. What we pride ourselves on is having a broader range of skills and expertise that allow us to have a detailed knowledge of the operational technology of the production equipment, the PLCs, the barcodes, the RFID scanners that enable us to capture the right level of detail and information. We then obviously have the software and the services associated with that to capture and do the analysis. But we follow that up with two key areas really. First is operational support, ensuring that systems run effectively, that the data is cleansed, that reports refresh and run on time. But perhaps very importantly is operational excellence. So once we've captured all of this information and it's telling us that our top loss reason is speed losses or performance losses, what do we do with that? How do we go about trying to understand how to make corrective actions and improvements? And we can offer the services and the consultation from an operational excellence or a lean perspective to help you work with that if you don't have those skills or those resources in-house. Some of our customers again here in the UK and overseas, highlighted on the screen in front of you. At that point, that brings us to the end of the webinar, and I will hand you back across to Hannah, who can take some questions that may have been submitted on the board.
Thanks, Fraser, for that informative presentation. If you have a question, please submit using the controls panel. Just to remind you that we will be sending out the recorded version of the webinar over the coming days so that you can re-watch and share with your colleagues. If you can think of any questions after, please email them to inquiries@cimlogic.co.uk. Hi Fraser, we have had one question submitted. If I have never recorded OEE before, should I start with a manual process or go straight to automatic data collection?
Okay, thanks. That's a good question. Certainly a manual OEE based recording system will give you a very good start. So it'll enable yourself, your team, your operators to understand the calculation of OEE and where the metric comes from. That's quite important when it comes to considering getting operator level buy-in and engagement to this new metric that perhaps you've not used before. So that's very good. However, it will give you the drawbacks that the data may be inaccurate, it may be open to manipulation, and it certainly won't be timely. There's going to be a lot of effort required to do the number crunching and the data gathering, plugging it all into Excel and doing that analysis. So what I would say is it can be quite simple to deploy an automated system to calculate your OEE and that system to also engage with those operators. Essentially, if we're talking about a line as a single entity, in order to calculate its OEE, all we really need to do is perhaps use two product counting sensors. One can count the products into the line, one can count products out of the line. Using those two sensors, we'll be able to derive when the line is not running, i.e. an availability loss. When it is running, how fast was it running, i.e. our performance losses. And the difference between what goes in versus what comes out should be our quality losses. So quite simply, you can get the accurate information that you can use to populate your OEE calculation, your OEE metric, but still add on the important operator context that I discussed about why did this particular line stop. So I would say there's definitely a balance, and it's not as hard as some people might think, or not as time consuming as some people might think, to take that first step to a very simple automated solution that will give you quite a lot of benefits.
Okay, myself and Fraser would like to thank you for joining us today and hope you found this webinar useful and informative. Thank you, goodbye.